Hi class, today we're looking at the converse of the Pythagorean theorem, or the Pythagorean theorem converse. So we all know that Pythagorean theorem is used on a right triangle. We also know that a squared plus b squared must equal c squared. So now what we're looking at is if c squared is equal to a squared plus b squared, then we know it's a right triangle. What we're going to look at today is, well, what if it's greater than? Or what if it's less than? So we'll get into that topic toward the end of the notes. At the beginning, we're just going to recap Pythagorean theorem. There are Pythagorean triples. These are numbers that if they were numbers around my right triangle, given that the biggest number was my hypotenuse, for instance, this was my hypotenuse, that was my hypotenuse, hypotenuse, we can say that 3 squared plus 4 squared is always equal to 5 squared. 5 squared plus 12 squared is always equal to 13 squared, and so forth. Any of their multiples will also be considered will also make a right triangle, will hold true for a right triangle, that a squared plus b squared would equal b c squared. So if you want to memorize those, you can. If you don't, it's fine. The most common ones you do see, though, are the 3, 4, 5, and any multiples of it. So for instance, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. That 6 squared plus 8 squared is also equal to 10 squared. So any multiple of it would be true. The other famous one is the 5, 12, and 13. So these two triangles are the ones that we usually see, and then we'll randomly see these as well. Okay, so let's just talk about Pythagorean theorem in general. So let's just apply Pythagorean theorem to some word problems. It says Randy made a ramp for his dog to get into his truck. The ramp is 6 feet long, and the bed of the truck is 3 feet above the ground. How far from the back of the truck does the ramp touch the ground? All right, so let's go ahead and draw our little truck. So here's my truck. All right. All right, there's my truck. All right, there's my window. My window's right here. And here's the ramp to get onto the truck. The ramp is 6 feet long. The ramp is 6 feet long. And the bed of the truck is 3 feet above the ground. 3 feet above the ground. How far from the back of the truck does the ramp touch the ground? So they want to know that part right there. All right, so with these word problems, there has to be a right triangle somewhere. In this case, it's here at the back of the truck, right? Here's the ground. All right, so the question is, how far from the back of the truck does the ramp touch the ground? So reminder that with Pythagorean theorem, the C is the most important one. So this is our C. All right, let's go ahead and solve it. Let's see. 3 squared plus x squared equals 6 squared. All right, that's 9, and that's 36. Am I going to add these or subtract them? Subtract them? Okay. All right, reminder that I'm still asking y'all not to give me any decimals. There's no decimals. So the question is, can I break up the 27? What will go into 27 of our perfect squares? Good, 9 and 3. Which one reduces? 9 becomes 3, and then square root of 3. It says round to the nearest whole foot. Don't worry about that part. I want you guys to still continue keeping things in square root form. Okay, so just leave it as 3 square root of 3. All right, let me go ahead and give you guys a moment to try the next one. All right, it says the map below shows 2 different routes Miss Benson can take to drive to the airport from her house. How many miles could Miss Benson save by traveling on Airport Road instead of Mountain Highway and Oak Road to get to the airport? Again, it says round. I'm not going to have you guys round. I'm going to have you guys, the answer is it going to be in decimal form. So no, I'm not going to have you guys do rounding there. All right, let's see. Okay, so the question is, how much does she save by traveling on Airport Road? So how much does she save by going down this road instead of going down Oak Road to Mountain Highway? So let's just figure out what Mountain Highway is, because we don't know what that is. All right, so let's do 25 squared plus x squared equals 65 squared. All right, so that'll give us 625. And this will give us 4,225. All right, our difference is going to be 3,600. Can we take the square root of 3,600? Just try it. We do, right? All right, so x is equal to 60. All right, so that's 60. All right, so if we're talking about this blue route here from Oak Road to Mountain Highway, so we're talking about Oak Road and Mountain Highway, that would be 25 plus 60. And how much is that? 85. Good. Now, the shortcut, Airport Road, this is just 65 miles. So the question is, how much does she save? What should we do here? Good. We should subtract. All right. So step 3, we should do 85 minus 65. What does that get us? 20. Good. She saved 20 miles. All right. Let's see, who can give me the formula for the area of a triangle? Who can tell me what the formula for area of a triangle? Oh, it's okay if we don't remember, right? Area is equal to half the base times the height. It's also written, and this is how you'll see me write it. It's just base times height divided by 2. Same thing. Same thing. The only difference is that the fraction was pulled out. All right. So it says find the altitude and the area and perimeter of an isosceles triangle with legs that are 20 and 24. All right. So what do we know about an isosceles triangle? Hopefully you're telling me 2 sides are equal, because we should know that. All right. So 2 sides are equal. These are called the legs. And your base is 24. First thing they want to know is the altitude. The altitude is another word for what? What do we call the altitude? The height. Good. So they're looking for the height. All right, so let's find the height. Let's all draw the height here. If the height is drawn, it should be perpendicular to our base. Okay, so I'm going to go ahead and shade in the triangle I'm going to focus on. I'm going to redraw this triangle. If you want to redraw it, you can. All right. So we have 20 here. I want to know the height here, which is right there. What's the bottom going to be? Am I going to put 24 here? Is the whole bottom 24? Well, the whole base is, right? The whole base is 24. We can say this is the base of the entire triangle. But if I'm focusing on just this half or this right triangle inside, what would that base be? What would this base be in here? From here to here. It would be half, right? So that would be 12. Okay, so let's go ahead and find the height. Let's do height squared plus 12 squared equals 20 squared. So just Pythagorean theorem. Okay, so here we have height squared plus 144 equals 400. Let's subtract 144. What would our difference be? 256. Now, we are not getting decimals, right? So let's see. Can we take the square root of 256? Always see if you can take the square root of a big number before you try to reduce it. Do we get a whole number? We do. All right, so the height is 16. We answered the first part. Find me the height. Done. We can cross that out. All right, now let's find the area. So the area, mind you, I had you guys write that formula up here. The area is base times height divided by 2. Well, we found the base. What did we label the base? 24. Good. So this is 24, and we just found the height. We said the height was 16. Good. And then divide it by 2. So 24 times 16 divided by 2. Our final answer here would be 192. And this is in inches, so they would be inches squared because it's area. All right, and then the last thing we're going to do is find the perimeter. So area is done. Let's go to perimeter. For perimeter, you're just adding the sides. And again, the focus is this big triangle, right? This was the base. This was our height. What's the perimeter of the bases? What's the length of the sides of my triangle? We have 20, 24, and 20. So we're going to add 20, 24, and 20. 20, 24 and 20. What do we get for the perimeter? Should be 64 inches. Okay, so I'm gonna have you do the same thing. I'm just gonna have you do one just so you guys get time to work on homework. All right, so let's try just practice 2A. Let's just try practice 2A. All right, good practice. All right, let's see how we did. I know we all may not be done, but let's just see how much we have. All right, so I'm gonna focus on half this triangle. I wanna know the altitude, which is the height. And because I'm focusing on just this half of my triangle, what would I put to represent this side? Half of 30 is what? 15. All right, 15. All right, so to find the height, we're gonna do h squared plus 15 squared equals 18 squared. H squared plus 225 equals 324. All right, let's subtract 225. What do we get when we subtract 225? 99? All right, if we try to take the square root of 99, we do get a decimal. So we have to try to reduce it. What goes into 99? Good, 9 and 11. And which one reduces? The 9, good. So 9 becomes what? 9 becomes 3. So h is equal to 3 square root of 11. Okay, so there's our height. What is the base of the entire picture? Should be 30, right? Sorry, my pen isn't connecting. Okay, this is my base. All right, so to get the area is just base times height divided by 2. We just identified the base as 30. What did we find the height to be? 3 square root of 11, all of it divided by 2. All right, so what can we multiply? Do I want to multiply the 30 by 11? The 30 by 3? What do I multiply? The 30 by 3, good. All right, so then that would be 90 square root of 11 divided by 2. Can we do anything else? Yeah, we can reduce that 90 and the 2. So area is equal to 45 square root of 11, and this would be feet squared. All right, and then we have one last thing to find for this triangle, and that is the perimeter. So for the perimeter, we're just adding the 3 sides. We have 30, 18, and 18. And our perimeter here would be 66 feet. All right, when you're ready, we'll go to the last page. All right, the last page. So converse of Pythagorean theorems. So first thing you want to do, you always first want to check, do we even have a triangle? Do we have a triangle? And remember, that's where you take one side plus the second side, and it has to be greater than the third side. Has to be greater than. Remember we did it 3 times? We had a combination, and you had to, let me just remind you, let's see, we had 2, 3, and 5. We did 2 plus 3, is that greater than 5? Then we did 5 plus 3, is that greater than 2? And then 5 plus 2, is that greater than 3? Remember we did all 3? And the moment you saw one that didn't work, we said, okay, that's not a triangle. Remember that? Okay, well, we have to do that first, but I'm going to show you the shortcut now, now that we've tested that. And then we're going to decide what type of triangle is it. So once you decide if it makes a triangle, you're then going to decide. So the first thing has to be true. We have to have a triangle. Okay. Once we identify it, if c squared is equal to, then it's a right. If it's equal. If your c squared is greater than a squared plus b squared, then we have an obtuse triangle. And then if c squared is less than a squared plus b squared, then we have an acute triangle. Now, the reason I focus on the c is because that relation to a squared plus b squared kind of allows our brain to make that connection with just angles in general, right? Anytime we think obtuse, we think greater. Anytime we think acute, we think less than. So if we focus on that c squared, if that's greater than, hopefully our brain will automatically go to obtuse, less than will go to acute. But if it's equal to, then it's a right triangle. Okay, so first thing we're going to do is decide if it makes a triangle. All right, let me go ahead and erase this part up here that we don't need anymore. Okay, so anytime you have a square root, what I want you to do is go ahead and just take the square root, and you're going to give me the decimal, but we're going to use this we're only going to use this for the first step. So if I take the square root of 198, I'm going to get 14.07. Now, the first step is, do we have a triangle? Now, the reason I have you write the decimal is so that you can pick the biggest side, because what has to be the biggest side? What on a right triangle? The hypotenuse. Good. All right, so you have to pick the biggest side. Here my biggest number is 16. So I know I'm going to take 7 plus 14.07, and that has to be greater than 16. So if you take the two smallest sides and compare it to the large side, you don't have to do 3 steps like the way we used to. You can just do this one step. So if I take 7 and I add it to 14.07, is that bigger than 16? It is. Good. So here we're going to say, yes, we have a triangle. Then you can proceed to step 2. So we already have this in order. 16 is my biggest. So I'm going to write 7 squared. I'm going to come back to my square root because I really don't want to have any decimals if I don't need to. We only use that decimal for the first step. Once we're done with that first step, we don't need it anymore. Okay, so 7 squared plus the square root of 198 squared. The question is, how does it compare to 16 squared? Well, 7 squared is 49, good. 198, the square root of 198 squared is 198, and we're going to compare this to 256. All right, we get 247 when I add 49 plus 198. Look at your 256. Is that equal to, greater, or less than 247? Is it equal to, greater, or less than? Greater. So then this is an obtuse triangle. Okay. All right, let's try it again. You're going to convert this to a decimal only for step 1. So when we convert this to a decimal, I get 9.05. All right, step 1. Do we have a triangle? All right, what's my biggest number? 41. So that's the one that's going to go to the right. So I'm going to take 32 plus 9.05. Is that greater than 41? Yes. All right, so we're going to say, yes, we have a triangle. Only if you have yes are you proceeding to step 2. All right, so now we go back to the square root. So 32 squared plus the square root of 82 squared. How does it compare to 41 squared? Well, we get 1,024. And what happens when you take the square root of a number and then square it? We just get that number, good. And then 1681. Together, this is 1,106 in comparison to 1,681. Again, when you're comparing the number to the right, the C. How does that compare to the other number? Is it equal to, greater than, or less than? This is another one that's greater than, so we have another obtuse triangle. I promise they're not all obtuse, okay? All right, this one's nice. There's no square root, so we can automatically pick the biggest number. And then we can do 11 plus 60. Is that greater than 61? So we're going to say yes, because that is. All right, 11 squared plus 60 squared. How does that compare to 61 squared? Well, here I get 121 plus 3,600, and this is 3,721. All right, let's go ahead and add these two numbers up in the front. Oh, what do y'all notice about this one? How is that number on the right comparison to that one on the left? Correct, it's equal to. So if it's equal to, what type of triangle is this? Which one did it say when it was equal to? When it was equal to, it was a right triangle. Okay, now they all don't come out to be obtuse. Again, the last one came out to be a right. But let's talk about that first step. So let me just do this one with you real quick. Our biggest number is 20. So step 1 about the triangle. 6.2 plus 13.8, is that greater than 20? Well, if I add those two, we get 20 is equal to 20. Is 20 greater than 20? So this is not a triangle. So do we go to step 2? No. No. You can't name a triangle if it's not a triangle, right? You can't say your pet's a German Shepherd when you don't even have a dog. So if you don't have a triangle, do not classify it. This is your answer, not a triangle. Do not go to step 2. You're going to go ahead and go over to the next one, okay? All right. Hopefully you guys can follow those examples. Reminder that on the homework you're only doing, or actually your homework is all 8.2, so you guys will be fine.